How can we find the minimal spanning tree in a graph? Well, the Kruskal algorithm is the go-to solution for this problem. And now I want to show you how this works. So the input for the algorithm is a connected undirected graph with a number of vertices and edges. Each edge comes also with a cost function which states how much it costs to take this edge. The output or the goal is now to find a minimal spanning tree, which is a tree with minimal cost. It's also very important to know that the minimal spanning tree is connecting all the vertices in a graph. So now let's break it down step by step. First, we sort all the edges by the weights from smallest to largest. Next, we start selecting edges one by one, always picking the smallest available edge that doesn't create a cycle in a spanning tree. It's very important that we avoid cycles, because with that we can guarantee that the spanning tree doesn't contain any redundant edges. To show that better, let's consider another example. So as an input we have now this new graph, and like before in the first step, we sort now all the edges by the weights in a table. If we now add these edges one by one, we recognize that this edge leads to a cycle. To solve that, we skip this edge and then we continue with the next one. So as you can see now, we have found a minimal spanning tree in this example, and all you have to do is follow the steps I provided. I hope you enjoyed the video and that you are able now to find a minimal spanning tree with the Kruskal algorithm. Please leave a like and subscribe if you are interested in more such videos and tutorials. And yeah, see you in the next one. Bye!